Hello everyone, welcome to my channel. Today we are going to solve Codeforces 1452E. The title of this problem is two editorials. For the prerequisites, you don't really need any advanced knowledge to solve this problem, but we are going to use some concepts such as prefix sum, binary search, etc. to solve this problem. Let's go to the problem description. So in this problem, we have a ICPC contest that just ended. So there are m participants, number 1 to m. Also there are n contests and problems, which are also numbered from 1 to n. Now the editorial is about to take place. So there are two column authors, and each of them is going to tell the editorial of exactly k consecutive problems. So the authors can choose this segment of k consecutive tasks for themselves independently of each other. Basically, that is means that their chosen segments can coincide, intersect, or not intersect at all. So each of the 8 participants, they are interested in listening to the tutorial of all consecutive tasks from Li to Ri. Each participant always chooses to listen to only one the problem author that tells the tutorials to the maximum number of tasks he is interested in. So let this maximum number be AI. So no participant can listen to both of the authors. That means they are going to listen to only one author. And they are going to listen to the author which has the maximum number of matches with their interest. Now, for this problem, we need to pick the k consecutive tasks for each of the author in such a way that the sum of AI over all participants is maximized. For this problem, so we have input, we have n, m, and k, where n is the total number of problems, m is the number of participants, and k is the length of segment. So each of the authors can pick. So basically each of the author has a fixed length, and both of them can pick exactly same amount of problems. Afterwards, we are given m pair of numbers, where for each of the students, Li and Ri, the segment, the beginning and the end of the segment of the problem numbers which the ith problem is interested in. And as output, we have to print one single integer, which is the maximum sum of AI for all possible combinations. So how can we solve this problem? Well, what is the brute force approach of solving this problem? One thing we can do is we can iterate over each of the possible segments, correct? We can take each pair of segments that is possible, that can be possibly taken, and afterwards we iterate through all of the m participants, and for each of the participant we calculate the maximum number of matches for either of the two segments, and we add it to the total number of days. What we can do is afterwards we calculate the maximum of this sum in for all pair of numbers, right? This can be one way we can solve this problem. So what is the time complexity for this approach? First of all, iterate through all possible segments. How can I do this? To iterate through all possible segments, we can fix the beginning of each pair of segments, all possible pair segments. So initially we can fix the beginning of each pair of segments, right? If we do that, the segments are fixed, where the left segment, beginning of left segment is Li, L, beginning right segment is R. So we can do is we can iterate for each possible, for each L, R, for each L, and for each R. Now we iterate through all possible layers contestants for each of the contestants. Calculate maximum match with L or R. So we need to do is calculate the maximum number of match. So we need to do maximum number of match with L or R. So we'll have to basically check for L the number of matches we get, then for R the number of matches we get, and pick the maximum of them. That's that AI A of A, let A be maximum match with L or R. And what we need to do is initially we'll have a total of 0, total match of equals to 0, and afterwards for each contestant we'll calculate the value of A, which is the maximum match with L or R. Then we'll do is total match plus equals to A. And what we can do finally, best match, we can initialize best match equals to 0. And what we can do in the end, we can do is after iteration, after this iteration is over, best match is max of best match and total match. So the complexity of this problem, suppose if we can somehow calculate this part in O of 1, okay, then we'll see the complexity of this solution is complexity of the solution is O of the, what is the maximum possible value of n? What is the maximum number of segments? It is n, right? So we have n into n. So the total number of pairs, traversing the total number of pairs will equal as a complexity of n square. And finally, we will have m players. So the total complexity is of n square m. And since for the problem we can see that n, m, and k, the value of n and m can be 2000. So we have gotten a solution which is probably going to take us 2000 into 2000, 2000, which is basically 8 into 10 to the power 9. It is a bit too high for our requirements because the amount of time we have is 2 seconds and we cannot really accomplish this in 2 seconds. So what we'll have to do is if we want a brute force approach solution, we'll have to optimize the solution a little bit further. So one thing we can do to reduce the time complexity of our solution is we can take this calculation, and if we can somehow keep this two loop but remove this inner loop and instead calculate total match in O of 1 or O of log n, then we finally will get a time complexity of O of n into n or n into n into log n, which is going to be enough for the problem we are trying to solve. To understand the optimization technique we are going to use here, we need to first understand the middle punch technique that we'll be using in this problem. So let's take an example. We are given two players, player 1 and player 2, with a segment of L1 R1 and L2 R2. and we have given k equals to 4, and that means that each author is going to cover exactly k consecutive problems. So let's see how picking a segment affects the number of matches with each individual player. Let's say we pick this segment. We get 3 matches, which is also the maximum number of matches we can have with player 1. Now if we pick this segment, we also get 3 matches. But if we pick any other segment, we actually get lesser number of matches, correct? For example, let's say we start here, these 4 matches. We get, what is the number of matches we get? We get 2. If we start here, we get 1. Similarly, if we start here, we get 0, 0, and so on. Similarly, on this side, if we pick this segment, we get 2 matches. Here we get 1. Here we get 0. So we can see that we have a middle boundary right over here, and the further we get from this point, the lesser points we get, right? And we can also see a similar situation for player 2. However, this time the range covered by player 2 is actually larger than the segment itself. So for which segments we actually get the maximum number of points. If we start this point, for example, if we cover this segment, we get 4 matches. If we cover these points, we also get 4 matches. If we cover these points, but not this one, we also get 4 matches, right? So for these segments, we have 4 matches. However, if we start here, we get 3, 2, 1, 3, 2, 1. So you can see, if we take this middle point right here, then the further we get from this middle point, the lesser points we actually get. So how can we use this technique to optimize our solution? What you can do is we can sort the players based on their middle points. As a result, then we can iterate for each LR, which will be the pair of segments chosen by the author. So L will be the left segment and R will be the right segment. So you can see that first few players will be closer to L and remaining players will be closer to right, R. That means what you can do is we can use binary search to find the player position where the players are split into these 2 groups, where the left group is closer to L and the right group is closer to R, right? We can use binary search to find this position where players will be split between left group and right group. Each group corresponding to their respective segments. So let this position be pose. What we have here is that players 1, 2 pose will have more matches with segment L, and players pose plus 1 to M will have more matches with R. So what we can see that we actually have a range sum query here, right? So what we need to do is for segment L, we need to count the total number of matches for the range of 1 to post, and for R we have post plus 1 to M. And we can use several data structures to deal with this, and since our queries are static, we won't need to update the values once we have calculated them once. So what we can do is we can use some static data structures, and the simplest data structure is going to be a prefix sum. So what we can do is we can define that prefix ij, where I is the number of basically I implies the ith segment, okay? The segment starting ranging from, let's say, I to I plus k minus 1, and j is the first j number of players. So prefix of ij stores the total number of matches for the ith segment with the first j number of players. Prefix ij, total number of matches with first j players for segment I. And as you can see, segment I represents the length, say I to I plus k minus 1. Before we get to the implementation, I would like to show you one more optimization which we are going to be using in our solution. It's not absolutely essential, but it's better if you can use that. So before I said that we have two segments L and R, and we want to find the splitting point. So what you can do is you can use binary search to find that position, right? But we actually can avoid this binary search completely. Why you can do that? Let me show you an example. So let's say we have a pair of segments ij, where I corresponds to the segment ranging from I to I plus k minus 1, and j corresponds to the segment of j to j plus k minus 1. Okay, so I is the left segment and j is the right segment. So here I is smaller than j, and let's take another similar pair of segments. Let IL be a pair of segments similar to this one. Here I corresponds to the segment I to I plus k minus 1, and L corresponds to the segment L to L plus k minus 1. This time also I is smaller than L, but along with that we also have j smaller than L. So if we calculate the position for ij, let that position be, say, post j, okay? Let post j be the splitting point for ij. And similarly, let post L be the splitting point for IL. So what you can say is that post L will be smaller than post J. Why? Because J is smaller than L. Actually, let me just change it. J is greater than L. It also goes the same other way around, but it's easier to explain this way. So since J is actually greater than L, okay, or we can rewrite it as L smaller than J. Suppose L is also actually going to be smaller than pose, right? Is because when you shift the right segment and you move it closer towards the left segment. So what we get is that the players who previously used to have more matches with the left segment might have more matches with the right segment, correct? So the midpoint will always be shifting towards the left. So what we can do is, instead of manually calculating this middle point using binary search or split point, let's just say it, we can do is, let's say for I equals to 0, I smaller than n, I plus plus, what we can do is, initially what we'll do is say that split position will initialize it as n minus 1 because it will be 0 based. So for j equals to, now we'll take for the second pair. Second pair will start from the right and move towards I. J greater than is I, j minus minus. What we'll do is decrement split pose by 1 until we get to the splitting point. If you do this, you can see that the complexity of our solution will be much less than before. So previously we had our time complexity of, what was it, O n square into log n, but this time our time complexity is actually just O n square. Of course, your previous time complexity is actually not that bad. It may actually just pass the test cases, but this one is actually better, right? This one it makes our calculation more efficient. And when I show you in the implementation, I hope it will be much more clearer for you to understand. So now let's go to the implementation. So let's see, we are given three integer values initially, n and k. The n is the number of problems, m is the number of players, and k is the number of consecutive books covered by a single author. So we'll take inputs for each of the players, and now before I define the input, notice that for each player we actually need three values, right? First of all, we need to know the left end. After that, we need to know the right end of the player, and finally we need to know the midpoint. So it will be an array of 3. So for each player, initially we are given two values, the left end and the right end. And now we need to calculate the midpoint. Now there can be two cases. First of all, the range covered by that player might be greater equals to k. Okay, so what we have here is that if we start at L and end at minus k plus 1. So if we take the starting position, so for the author, which is anywhere between start and end, we are actually getting the maximum number of points, right? If we start between start and end, we can get the maximum number of matches. So the midpoint will be in between this, in between start and end, right exactly in the middle of start and end. But notice that if we do this division array, we'll actually be doing integer divisions, but we actually can round them down. So we need the floating point value, we actually need to do is floating point divisions. And since we are showing integers, we'll avoid it for now. And if we need to do this later, we can divide them by 2 later if we need to do that. And the second case that can be is that the range is actually smaller than k. In that case, if the start position is r minus k plus 1 and end position is l. So if we start anywhere between start and end, this time we get the maximum number of matches. We can match all the problems for the particular player. So the midpoint is in this case start plus end by 2, but we're going to be avoiding the integer division there. Now, so how we are going to store this? So we are going to say player I will be midpoint and r. The reason that I have actually placed midpoint right here to declare to you later. Now we are going to sort the players. And this time, since we have stored the midpoint as the first index, right? This is the first value. We have stored the midpoint in the first index. So if we sort them, actually the players will be sorted in the non-decreasing order of midpoints. So, and this is going to be essential if you want to calculate, if you want to do range queries. So now that we have sorted the players in appropriate order, we can calculate the prefix sum. And for prefix ij, I refers to the ith segment. There can be n total number of segments. And j refers to the number of players, and there can be n total number of players. We are going to be using command-based indexing just for convenience. Now, we will iterate through each of the segments. And so for each segment, we are going to calculate the prefix sum array. So let's say for each segment I refers to the segment. I refers to the starting position of that segment, okay? Notice that I plus k minus 1 can actually exceed 10. This is actually possible, but this is not really a problem, because for in such cases, actually, our calculation is never going to calculate a better answer. I mean, in such cases, there are always will be a better alternative, so it is not going to be a problem. So now, we iterate through the array of pairs, theirs. So for each player, we actually want to know the total number of matches, right? Total number of matches with that segment. And how can we do that? We can do that by calculating the intersection area of the segment and that segment of the range covered by the player. So basically, we'll have to take start with a max of the starting position of our segment, which is I, and the starting position of the player, which is players J1. We know that players J1 refers to the starting position of the player. As you can see, players J1 equals to L. L is the starting position of the player. And we have the A value will be minimum of players j 2 and I plus k minus 1. So the total number of matches is notice that this value can be actually negative, but we never want negative values. It will always be positive, it will always be negative. So we calculate prefix of I j plus 1 equals to prefix I j plus matches. So we can get to the last segment of our implementation, which is to calculate the maximum number of matches we can have. So initially we would like to initialize with the minimum value that we are guaranteed to have, which is prefix of 1. Now we would like to iterate for each pair of segments, right? So let's take L is the left segment and R is the right segment. We want to iterate R from the opposite direction, like I explained before. Now before we iterate R, we also want to do one more thing. We want to know the last player that is actually closer to L. So let's say last L. Initially we will initialize with m-1. So this refers to the index of the last player that is closer to L. And as we iterate R, we actually want to keep decrementing this value until it points to a player that is closer to L. So while last L is greater or equal to 0. Notice that we also want to make sure that this value is actually greater or equal to 0. The reason is that there can be a case where all players are actually closer to R. In that case, the last L is going to be -1. So if it is that, so we don't want to access the memory in such situations. So we have to make sure that it conforms to the boundaries. And next, we need to compile the distances. So what we have to do is so what is this doing is basically that it is calculating the distance from the midpoint of the player to L and midpoint of the player to R. So as long this midpoint is actually closer to R, okay, so we want to keep decrementing it. We want to keep decrementing the index, right? So what we have to do is that we take the midpoint, we divide it by 2 because we actually avoided the division error, as you can see. And the problem arises is that this can be actually a floating point value, like it can be 2.5, but we are using integers here. We can't have floating point values. So we can use floating point values here, or we can also just use another simple trick, which is we can multiply it by 2. Since this is actually just a comparison function, this is actually not going to cause us any problem here. So now we know that players from 0 to last term in zero base index, from players from 0 to last L will be closer to L. so segment L, and lasso plus 1 to m minus 1 will be closer to segment R. So we can use the pre-calculated prefix sum array we have here, and we can use this to calculate this better. So let's say id matches L matches with left segment. This is going to be dx of I plus L plus 1, since this is 0 based index. I mean, since the prefix sum is actually calculated in 1 based indexing. And for matches R, we have prefix of Rm minus prefix of R lasso plus 1. So we want to update the total number, we want to update the maximum matches with this value, new found value, and the value will be updated as max of max matches and matches L plus matches R. So there we go. This is how we can calculate the maximum number of matches that is possible. So, and is the answer. So let's see if the solution has worked.